Good morning, everyone. Today, we're diving into one of the absolute cornerstones of science, the laws of thermodynamics. These laws govern how energy moves and changes in the universe. And trust me, once you understand these, you'll start seeing them everywhere. There are four main laws. Yes, four, even though they're numbered a bit weirdly. Zeroth law, first law, second law, and third law. Let's go through them one by one, and I'll show you real-life examples so you can actually feel how they operate. The Zeroth law says, if two systems are each in thermal equilibrium with a third system, they are in thermal equilibrium with each other. Simple English. If object A is the same temperature as object B, and B is the same temperature as object C, then A and C are the same temperature too. Thermometers exist because of this law. Example. If you have a cup of tea, and a thermometer shows 60 degrees Celsius, and another cup shows 60 degrees Celsius on the same thermometer, both cups are at the same temperature even if they feel different to your hand. The first law says, energy cannot be created or destroyed, only transformed or transferred. Meaning, energy might change forms, like chemical energy in food becoming kinetic energy when you run, but the total energy stays constant. Example, when you eat breakfast, your body turns the food's chemical energy into mechanical energy, movement, and thermal energy, body heat. In a car engine, petrol's chemical energy turns into kinetic energy, motion, and heat energy, exhaust. First law formula, du equals sine Q. W example, a gas engine absorbs 500 J of heat and does 300 J of work. The change in internal energy is 200 J. The second law is the most doom and gloom one. It says in any energy transfer, some energy becomes less useful, often as heat. Entropy, the measure of disorder, always increases in a closed system. Meaning, things naturally become more chaotic unless you put energy in to maintain order. For example, ice cubes melt in a warm room, spreading their coldness into the surroundings. The system becomes more disordered. And think about your bedroom. If you don't constantly tidy it, it gets messier. Higher entropy. So if your room's a mess, blame the second law, not yourself. The third law says, as you approach absolute zero temperature, the entropy of a perfect crystal approaches zero, meaning, at absolute zero, that's minus 273.15 degrees Celsius, particles stop moving completely. Perfect order, no chaos. For example, in ultra-cold physics labs, scientists cool atoms to billionths of a degree above absolute zero. At that point, quantum effects like superconductivity and superfluidity appear. Matter behaves weirdly. Alright, quick summary. Law key idea example. Zeroth defines temperature thermometers work. First energy is conserved eating food, running second entropy increases ice melting, messy rooms, third absolute zero equals perfect order, quantum weirdness at cold temps. Each law builds on the previous ones. Together they explain why energy flows, why machines lose efficiency, and why perpetual motion machines are impossible. In the end, the laws of thermodynamics remind us that nothing comes for free, energy-wise. Every action has a cost in terms of disorder. Absolute perfection, or zero entropy, is something we can approach but never truly reach. Understanding this doesn't just help in science, it changes how you view the world. Energy flows shape life, ecosystems, machines, everything.